Awesome.
All right. Well, thanks everybody for joining the third session of our second day of the Enterprise UX Virtual Summit. Today we have Chris Rivard here, who's going to be talking about designing data products. He has a lot of experience in designing data and data visualization driven products. So he's going to share some of his great insights with us today. The hashtag for this event is hashtag EUX Summit 2017. So I'm going to drop that in the box here. You guys would like to just see or tweet along. And let's see here. Yeah, I think with that said, Chris, I'll just kind of kick this over to you and we can go ahead and get started.
Awesome. Thanks, Jerry. So thanks everyone for joining. My name is Chris Rivard. I've kind of had a long and storied career in product design and user experience design. I've held many titles everywhere, everything from production designer all the way to information architect to design director. And I think the thread that kind of carries through much of my design career has been working with complex data sets. So kind of data intensive applications and then using large data sets. So to kind of level set this talk, if we were to talk about the type of design work that many of us are doing, it could be said that most of us are doing kind of data product design, using data as kind of a raw material for the products that we're building. We're incorporating.
Chris, sorry to just cut in here real quick. Would you mind speaking closer to the microphone? There's people.
Yeah, sure. Sorry about that, guys.
Yeah.
So I think for many of the products that we're building today, they could be said that they're data products. I think today many of the things that we're working on are data intensive. We're using data as a raw material, and so I think it could probably be said, data is the primary ingredient for the products that we're designing. Whether you're doing, granted you may be doing kind of a heavy visual interface, kind of stylistic interface design, but underlying all of those interfaces is kind of some access to design. So I think the term data products design is pretty broad. And so I think for the purposes of this talk, let's constrain our definition of products that leverage data as the raw material, and even the output of the products. And let's focus on how these products ultimately inform how our customers make good decisions. And I'm going to talk a lot about that, about kind of decision-making and sense-making based on data products. And that's kind of the focus of my work here at Cloudability. I'll kind of give, I have kind of a little bit of a historical background. I think that good designers are good anthropologists. And that's kind of a topic that I like to talk about. I like to research and kind of compare that to some of the things that we're doing today. So we'll take a little bit of a look back in time at some old data products, and then we'll kind of take it forward to some of the things that we're working on now. So data by itself is meaningless. What we give.
Chris, sorry to cut in again. Were you trying to move the slides?
Not yet.
Oh, okay, not
yet.
Just
about to get started, guys.
No worries.
Yeah, sure. So
some people mentioned there's still a slight echo. I don't know if you want to just go a bit closer to the computer, that might help.
Let me try to get a little bit closer and kind of look at the camera as well. So so through the context, data by itself is meaningless, and we imbue context and meaning to the data in our products, and ultimately to the experience of using our products. And so it's this subjective contextualization that gives meaning to the products we design. And so we're entering this really exciting phase of digital product design where consumers of our products, may no longer even be humans. There's a lot of machine-to-machine interaction going on as well. And I think it's an interesting question to explore how we're designing those types of interactions and building products for that machine-to-machine interaction. And so the role of the designer is really in brokering these interactions. We'll talk a little bit about that in just a moment. So let's get started. I'm going to go to the first slide now. And looks good? Okay, so I've organized the talk into three parts. First, we're going to do a quick survey of kind of how humans have sought to make sense of the physical world through external data, and how information was encoded and transmitted at the intersection of kind of social and economic transactions. I think that's in kind of history, that's really where things start to get interesting for us. In the second part, we'll look at some factors that influence how data products are designed, focusing specifically on biases in data. This is a big topic right now in kind of data product design. the effect of algorithms and biases that we kind of imbue into these algorithms that we write. And then in the final part, we'll look at some data products that we're working on here at Cloudability, and I'll kind of give you a kind of a case study example of some of the problems that we're running into and kind of our process for building meaningful data products. So let's get started. So this is the physical world. So throughout human history, we've sought to make sense of the world around us. Why does the sun rise and set? How long and in what direction of travel should we take to reach a destination? With the advent of mathematics, logic, and language, we're better able to understand the world around us. So kind of in this agricultural society, we started to trade and farm, and we had this need to transmit information and kind of keep track of stores. So what some trading arrangement, or how many livestock, or how much grain was traded between two groups of people, for example, in communities. And so at the same time, we started to encode information into physical artifacts. This was about 50,000 years ago. Mesopotamia Valley, kind of the intersection of the Tigris and Euphrates, kind of the breadbasket of civilization, if you will. And so this is an early artifact called a bula, and it's essentially a clay sphere. There's information encoded in the bula, so there's a recording of a transaction in the clay around the bula, and there's also materials inside the bula. So they were kept safe inside. It actually had to be broken apart to understand the details of the transaction. And it's interesting that this model of this kind of physical artifact, the security is essentially baked in. No one could hack into it or break into it to find out the details unless they actually destroy the object. Another example, kind of from ancient times, is what's known as a tally stick. And so these were first used in the Paleolithic period. And it's essentially, this is called a split tally. So it's a piece of wood with a transaction encoded onto the wood. And then the piece of wood is split in half. And so you have this bilateral arrangement. So if you were keeping track of some numbers, some economic transaction, one party would get one piece of the stick, another party would get the other part of the stick. To recombine or recreate the transaction, they'd have to be put together. And so if you can think of this in modern times, you can think of this as a precursor to the way public key encryption works. You have a private key and a public key. You keep the private key, you give out the public key. In order for them to come together, you have encryption and security. So kind of an interesting look back in the same model within a physical artifact. And so kind of moving forward to kind of the communities that we're living in, once we've established the farming communities, we want to start to, people started to migrate around the world. And, you can think of this question of where are we going, what's our place in the world? So in addition to recording the account of the economic transaction, we began to develop systems to provide more context to the physical landscape in which we travel. So this raises questions of direction and velocity. And so we have these metaphors that we still use today in enterprise and in software and in business. We have the topic of this conference, the enterprise as a sailing ship. We have roadmaps. We talk about the direction of the company, things like that. These are kind of metaphors that we've taken from this physical environment where a lot of these concepts originated. And so, kind of the last artifact that I want to touch upon is this object called a chip log. And this was used in a sailing ship to determine how fast the ship was traveling. So this triangular piece of wood was thrown over the back of the ship. Knots were tied in the rope. Using an hourglass timer, a sailor could count out the number of knots that were being paid out and determine how fast the ship was going. And so this is where the term knot for the speed of a ship came from. In modern nomenclature, we capture and process server logs as a raw material for some of our data products. So, from these ancient times, we're still recording and storing and processing information for later use. And so I'm thinking about these early artifacts. We have this idea of encoding information into the data products. In the bula and tally stick, we're conveying some directional information with the chip log. And then we're telling a story, so a transaction that occurred between some trading partners, or the speed of a ship and the direction of travel. So jumping ahead a few hundred years, considering where we live now, the times in which we live now, we have these early examples. They were primarily concerned with regarding a transaction. In a modern business context, our horizons have greatly expanded. So now we want to forecast and model outcomes. We want to project information into the future to derive insight for some decision that we want to make In financial markets and business planning, organizations create financial forecasts and annual budgets. The concern, in the present day is based on the information I have at my disposal right now, what can I expect in the future? So we're starting to kind of project out. And this is interesting in data product design. One common theme that I run across is this question, and I'll revisit this a few times. It's kind of, what should we do? What action should we take based on this information we have, based on how we're deriving this the information from this data in this algorithm? What should we do? Should we go up or down, left or right? What decisions should we make? And so there's this problem. Peter Drucker is kind of an infamous management consultant. Kind of a great quote from him. It's a bit impossible to tell the future, even with as much data at your disposal as we have now. And so, right now we live in this world of complex dependent systems, and the pace of change is only accelerating. One of the charges as designers that we have is to simplify. And so make it easy to use, make it delightful, make it snappy, make it pop, make it awesome. You've probably heard a lot of those requests from your stakeholders or customers. And so how do we design products that allow our customers to make sense of this complexity of complex systems? A lot of people have thought about this problem in the fields of sense making and decision making, and I'll touch on briefly just two frameworks for decision making that are kind of in the field of study right now that we can kind of think about when we're designing data products. So maybe you have heard of this one. This is from John Boyd. He was a military strategist. He came up with this theory of the OODA loop. This is kind of a theory of decision making. It was typically used in actually warfighting and fighter aircraft. If you were in a dogfight with another plane, you're attempting to outmaneuver the other pilot. So, this has been applied to business contexts where you're in some negotiation in business and you're trying to quickly move through some framework that you can make sense of observable data, orient to that data, make a decision, and act very quickly. So you can think of these loops as kind of quick iterative loops. Another one is from Gary Klein, kind of another stalwart in this kind of decision-making framework field. This one is naturalistic decision-making. So this is typically, Gary Klein studied a lot of kind of high-pressure situations, policemen and firefighters trying to make very fast decisions based on information they had. And so in this kind of naturalistic decision-making, there are a few different flavors. There's kind of the first idea is best idea. And so that's kind of, I'll touch on this in just a moment, but Daniel Kahneman's thinking fast and slow. So this is kind of the fast thinking. The first idea that pops into your head is the idea that you should go with. Or there's kind of a scenario building where you're starting to model different scenarios out and kind of think through these different mental simulations in order to reach the best decision. Or there's kind of an iterative targeting where you're evaluating all of your options and then you decide which option is best. That's probably the slowest form of decision making. And so typically our work as designers has to do with more of an economic benefit or behavior change. We talk about things like engagement or signups or units sold. But as we move toward increasing layers of abstraction and automation, the effects of systems we design are going to have more real-world consequences, and they're all mutually dependent and interdependent. And so the complexity is essentially increasing. And so I want to look at an example of kind of real-world decision-making, and then kind of think through that. I want you to keep in the back of your minds, is there some data product that could be designed to satisfy this need? And I'll kind of go through this example. So, typically what we're looking at here is just kind of this is Forecast.io. This is kind of weather data. We can see this anytime we go out. If we check the weather in the morning, we want to find out what the weather's going to be for the day. Should we bring our umbrella or rain jacket? And typically, when you're looking at weather data in all of our daily working lives, we're usually not concerned. It's not a life or death situation. 99.999% of the time, you might get wet, but you're not gonna. It's not gonna be a disaster if you forget your umbrella. But there are situations when the physical environment, where the risk is increased, and so this information takes on more importance. And so here we're looking at just kind of unstructured, generally structured data from weather stations. On the left, we have Mount Hood in my home state of Oregon, and on the right, we have this information from the San Juan Mountains in Colorado. So looking at this data set, we have wind speed, wind direction, wind maximum gust, elevation, precipitation, and temperature. And so we have all these series of inputs. And so if we were standing outside next to one of these weather stations, we'd be able to say the wind is blowing hard or it's not blowing. We would be able to use our faculties and our senses to make some approximation of what's going on in the physical environment. So in a sense, sense making, using our physical senses. And so typically this is the data that an outdoor recreationist might use when they're making a decision to go into the backcountry, for example. And that's the example that I want to touch on. So say, for example, they're determining the risk of avalanche danger when they're going into the backcountry to go skiing. And so we can start to provide some more context, apply some context to this data. We can start to visualize it in different ways. This screen here, we're looking at this triangle on the left is the cylinder basically representing a mountain above tree line, near tree line, below tree line, and kind of what the risk is at those different elevations. And there's a danger scale here. So no rating all the way to a 5 extreme. And so this is also temporal. We have today's forecast and tomorrow's forecast on the left and right. We can kind of further visualize this into kind of this rose diagram where we see aspect and elevation. So if you think of this as looking directly on top of a cylinder, we can get the aspect. So is there danger at a different aspect of this cylinder, this mountain? And then interestingly, in the foreground image here, we have this, we have a label for likelihood. And so this is interesting because it's an interpretation of the data. And so, what someone has done, a human has done, is taken all of this weather information and they've derived a probability that something may happen. And so we typically, in the design of data products, we typically don't get this kind of, likelihood of something. A lot of times in a business context, someone wants to know exactly what to do. What action should I take? Just tell me the answer. And my point here is that it's not that simple. And so I'll briefly touch on this. This is actually an avalanche occurred in Colorado. This is actually the scene of the accident here. And so given all of these inputs, given all of this data, given the available information for someone to make a decision whether or not to go into the backcountry, this accident did occur and there were fatalities in this accident. Is there a data product that could have been designed to prevent this type of accident from occurring? And so I would say the answer is no, and there's a complicating factor here. And the complicating factor is people. And so in snow science and in avalanche training, there's this concept called human factors, and there's an acronym called facets. As recently as the past, I would say 5 or 6 years, training had been focused on kind of more of the quantitative aspects of conditions in the backcountry. So there was recent snowfall, there was wind loading, there are instability layers. And so this was kind of the science behind how to make this decision. And more recently, training has actually focused more on human factors. And this facets acronym, these are a couple of the factors included in human factors in this specific use case. Familiarity, is the user familiar with this area that they're going to? Do they accept the risk? There are group dynamics involved. There's an expert halo. A lot has been written in the design of products just about experts and who is an expert and who's not an expert and how we trust experts. And in this kind of social facilitation of I don't want to look dumb in front of my friends, so therefore I'm going to do the same thing. And so my point is that there are kind of these we have fallacies, we have cognitive biases that are included in the decisions we make. And those are really imbued in the algorithms that we write in order to, in the case of data products, provide some context to our customers. And so Gary Klein actually has an interesting quote about algorithms and about kind of depending on algorithms. And he's stating in this quote that we get more passive and we get less vigilant to our actual natural sense-making abilities when we start to overly rely on algorithms. And so you've probably heard things like confirmation bias, we're confirming our preconceptions or what we think we know to be true, or we have recency bias in data where we're more heavily weighting recent information over older information. And I think there are some things that we can do as designers to kind of counter these biases that we have. The first being that we should be aware of these biases, and you can Google this and look up all of the biases, and there are a few that typically bubble to the surface. And this might be a little too zen, but have a beginner's mind, and I think this is really the aspect of empathy. This is the idea of empathy for your customers. What are they expecting from this data product? What action are they expecting to take? How are they expecting to feel in a qualitative way when interacting with the product that you're designing? Kahneman and Tversky have written a lot about this. I've actually included some sources at the end here. Thinking Fast and Slow is a book, and then Gary Klein's information as well is pretty fascinating here. And so we need to make decisions, and we need a framework to kind of contextualize the data in order for it to be actionable. And that's kind of what we're talking about when we're building these data products. In a business context, the ramifications of making a bad decision might be a financial loss. Rarely is it any kind of life or death decision. The most common scenario is tell me what I need to know, provide me with the information so that I can make an informed decision, make my operations more efficient, so save me some money, or entertain me based on what you know about me. So recommendation systems in consumer products are typically doing this. And so this is really where data product design begins. One of the most important and difficult phases of setting out to design a meaningful data product is really kind of coming up with a question that you're trying to answer. I think oftentimes I've seen stakeholders realizing that they have access to this vast amount of information, this vast amount of data. They start to want to kind of interrogate the data to ask, just show me the data. What does the data look like? Help me visualize it. And I think that's the wrong approach. The right approach is really to say, well, what question are you trying to answer? And so when going through that exercise of determining the question that you're going to try to answer, you start to really focus on the data that you have, the ability for that data to answer that question, and really it kind of identifies gaps in where you may not be able to answer that question at all given the available data. So number one, formulating the question and determining what question you're trying to answer. There are relatively simple questions. Where do Uber drivers frequently travel in Manhattan? These questions can easily be charted, visualized, and answered. Usage data can also be used to build recommendation engines, as I mentioned, using social signals as raw materials, so likes, comments, replies. You may also like this, movie, topic, person, location, any kind of system that would recommend something to you. In that, a quick side note on that, recommendations they present challenges because they really prevent serendipitous discovery of information. So what happens is you have homophily, where you kind of users get siloed off into groups and rarely cross paths. And so this is a problem in a lot of social networks where you actually probably the news media and Facebook is probably the best example of you're kind of only exposed to information from the group that you've been siloed into. Other examples, kind of a counter example to a recommendation engine might be something like an Amazon logistics algorithm for fulfillment. So shipping products to your house. So that's kind of what is the recommended best way to get this product to your house as fast as possible. So there are companies that are working on those types of problems as well. In this example, this is one of my favorite data visualizations. What's the increase or decrease in spending by department in this budget? So this is an interactive visualization. I would say this is kind of beyond what we might call just a infographic or data viz. There are multiple metrics imbued in this visualization, and it's interactive. And so, thinking about where I am at Cloudability and kind of the work that we're doing here, and I'll give you a kind of a brief 30 seconds of overview of kind of the work that we do here. We work closely, as a product designer, I work closely with data scientists. I'll talk about the process in just a moment, but the process is typically, it's very iterative, it's very kind kind of discovery focused. It's very experimental. This is one of the risks in kind of designing data products in an organization. They typically start out maybe as an R&D project. You're kind of hacking a little bit. You're kind of scratching your own itch. Why is this thing occurring, or can we access this information? And I think there's the combination of data science and design. It's a great partnership. And I think as far as kind of skills to learn, as a designer, I think it's extremely valuable when you're designing data products to try to better understand what your partner in data science is up against. What tools are they using? How are they modeling things? How are they prototyping things? What issues are they facing? I think it's really a partnership, and it's not just the data scientist has some information that they want to create a visualization from. I haven't found very great products that come out of that type of arrangement. And so, powerful combination. We're kind of designing. You're kind of designing for action. There are two examples of. You can design for just information awareness. You should be aware of this thing that's happening in your system, or you're actually designing for action where the data product is informing you of an action to take to remedy some situation. So where the projects that we're working on here at Cloudability, this is kind of a rough, I know that I've actually watched some of the earlier presentations, and there's a lot of kind of heavy enterprise UX process focus. I would say doing data products, it is very, we're kind of iterating very fast, and we're trying to come up with a product or come up with a solution as fast as possible so we can test it, validate it, and then move on. So we might do something like, data scientists might run a query across a very large data set. That might take some time to get that query right and get the data back. I'm trying to avoid saying the word big data, but very large data sets. There's a process where we clean the data. It typically doesn't come back in very good shape. So either I, as the product designer, or the data scientist will work together to kind of clean out the data, remove records that are irrelevant or kind of are outliers. And we'll typically test a very small sample set. And I think this is really the crossover between data science and product design. So typically I'll prototype in a tool like D3 or Dribble.js or some other prototyping tool. I'll just take a small data set. We might be using 100,000 rows of something for the final product, but I might just take 50 rows and do something very fast to get a prototype working. Once we have that operation going and kind of churning, then we'll start talking about building it for production. As we continue to test and iterate. And so I kind of have this I have this graph of kind of the data continuum, and it's really in thinking about this, it's really where we spend the most time. And so there is the initial discovery period where we're formulating the question that we're trying to answer. We're collecting data. It might be unstructured data across multiple sources that we need to aggregate together and then query. The most of the time at the top of the peak here of this curve is really the process of cleaning the data. And so there's a ask anyone in data science, the joke is that you spend a lot of time, the 80-20 rule, you spend a lot of time cleaning up data and preparing it for use. And then kind of as we go off to the right on the screen, we're kind of interrogating the data, we're testing our hypothesis, we're testing if this data can answer the question that we've asked. And then we decide whether or not we need the user to take action based on this, or if it's just awareness. And I'll speak to that in just a minute, because I think it's very relevant to the work that we're doing here at Cloudability. So let's see. So to kind of sum up so far, meaning is context, and the context is typically time sensitive. Things are moving very fast in the business world. And we need to provide some sense-making capability. A data set can be very abstract, so we need to kind of imbue this context so that the user can make sense of what they're looking at. And we want to provide some directionality. What action should I take? Given a series of options, what's the best one for me? So we have context and sense-making, and then we have this aspect of time. And I want to add a third that I'll kind of touch on at the very end, and that's kind of ethics. I don't know if anyone else in the conference has been talking about design ethics, but I think when it comes to data products, there is a strong component of ethical decision-making, ethical decisions on the designer's part of how to present this information. I'll get back to that. And so let's walk through a couple of examples of some of the products that I'm currently working on. and I'll give you kind of a 30-second overview of what cloudability does. So the short story is that most enterprises are moving from a fixed data center where they have fixed costs, they have hardware that they've purchased in the data center. They're moving that to the cloud. So Amazon Cloud, AWS, Google Cloud, or Azure, Microsoft Cloud. And so there are these options for them to lease hardware, essentially. It's a pay for what you use model. Typically, it's paying for the hour in the case of AWS. And you have these different concepts that you didn't normally have in a data center. You have these concepts of elasticity and efficiency. So how elastic is my cloud architecture? Can it grow and scale based on the needs of my product or my application, whatever I'm using it for? On top of that, you have just the management and the billing complexity that's built into this hourly utility model. And so what cloudability does is manage all of that spend. So AWS, for example, has a daily billing file. It comes out every 24 hours, and it categorizes every resource. And by resource, I mean a piece of hardware or some compute, storage, memory, and there's a price for that. And so, we've really gone from kind of the operating costs of purchasing a fixed asset to leasing hardware and paying per use, and kind of the cost of goods sold. So how much am I spending and how does it relate to the product that I'm selling? So the economics have shifted in the past few years as cloud has come to dominate how enterprises are managing their infrastructure. And so that's what cloudability does. We help manage their cloud spend. And so a question, EC2 is an elastic compute cloud. It's kind of the workhorse of a cloud architecture. It's kind of the compute machines or the storage machines or the networking machines that customers typically lease from AWS, for example. And there are different sizes of machines that are used for different tasks. So it's kind of a plethora of combinations, a matrix of what you would use these machines for. And so that's the biggest spend. So a lot of times customers ask us, well, how much am I spending on my EC2 instances, and how can I get that cost down? And so our product, we typically chart all of that data. So we have things like how much are you spending by family, we have your overall costs. We can go into a specific resource. Every resource has an identifier. We can tell you how much that resource costed you and how many hours that you used it. There's also a concept of reservations. These are essentially coupons. So someone can make an advance payment on a piece of hardware and they can save some money. So it's a good idea to make a reservation. You reserve the capacity. If you use it, great. If you don't use it, you haven't spent as much money as on demand. On demand is I'm going to turn something on and start paying for it immediately, but I have no reservation on it. And so this is one of the entryways into our product, the product dashboard, kind of an explorer for elastic compute cloud instances. And so one of the projects that we worked on in the last year was affectionately known as kind of zombie hunting. And so what we were trying to do is find underutilized resources. So it's common that a customer may turn on a bunch of hardware and then they forget that it's running and they're actually being charged for it. So this is kind of in the data product design, this is a cost saving mechanism. So how can I save money by turning off these instances that I'm not using? And so the task that we had kind of on data science and product design is, is there an algorithm? What is the algorithm that we can write to identify these zombies and then present it in some way that the customer can take action? And so interestingly, in this example, we don't always know what these are. So when we show this product to customers, they actually have the mental model of their architecture, and so they know, we'll surface the biggest zombies, we'll surface them to the customer, and the customer makes a decision of, oh, I know what that is, and I don't need to turn it off, or I know what that is, and I forgot about it, and I'm going to save a few $1,000s by turning it off. And so I have included this term right sizing. The concept of right sizing is essentially taking something in one form that might be over capacity or under capacity and kind of changing it so that it's a kind of Goldilocks, so that it's just right. Not too big, not too small, just right. So it's kind of the concept of right sizing. And so, this is our first kind of beta of this program. And again, we do a lot of charting, we do a lot of visualization. In this context of the beta release of this, we really wanted to tell the customer that, we wanted to identify what the most underutilized resources were and tell them how much they were costing them and allow them to make a decision. So there is a question of kind of automation. Is it better for the system to automatically do something to those? And we've made a decision early on for this first release that we really just want information awareness. We want the customer to just kind of know what they're looking at and highlight those resources. When we think about the algorithms that drive something like this, in the left column here, you can see we have something called the priority. And this is a lot of times, interesting in product design, we spend a lot of time thinking about what we call things. You know, we kind of, there's a kind of this linguistic exercise of, do we call this the score? Do we call it the, you know, underutilized whatever? You know, they're kind of these examples of priorities or metrics or measuring something. And all of these have kind of, they have meanings to the customers that are looking at them. And so in this context, we said, let's just call it the priority. We dropped the word score. We have score over on the right, where we are calculating kind of the idle of this machine, the CPU usage, the memory, disk, network, in and out. And then we give it a kind of a utilization score. So there is a complex algorithm that's kind of driving this, which is kind of another, you know, another situation in developing data products. We do have customers, and in past roles at other companies, you know, customers will ask, how is the algorithm put together? I want to see the algorithm. I want to see how you're ranking these things. And so I think that the challenge in a lot of data product design is to really, you want to kind of present the information to make it understandable, comprehensive to your customers. And you have to make a decision whether or not you kind of let the customer into how you're kind of making, you know, coming to these conclusions. And so, you know, it's a challenge. I think this is our beta release of this. The next version, we might remove some of this information. I think what we've seen in kind of showing this to customers and kind of talking them through it, they have a very quick at-a-glance mental model of their infrastructure, so they understand what they're looking at right away. And so it's not necessary that we kind of give them all of the evidence that we have right away. They can identify it. The evidence can kind of be rolled into the algorithm. They don't necessarily need to know that. And so one more project I'll briefly mention, this kind of weekly scorecard. So we typically send out an email once a day that says how much a customer is spending on their infrastructure. And so this, you know, they'll have a budget, and then how close are they aligning to their budget? Are they going over their budget, or are they tracking under their budget? So we typically send a daily email out. And what we were trying to do in this project is to create kind of a weekly scorecard and measure how elastic their environment was. And so, again, we can look at kind of a dashboard-esque interface. Again, we've scored it. I mean, this is very common in data product design, where we're kind of giving it some score as a first pass. And so this, you know, we did include in this interface the definition. You know, does this customer's architecture have the ability to scale up or down, and what is the score relative to other cohorts? So in a cohort of 45 similar organizations, where does this organization fall? And then how much are they saving? So these two lines here are tracking their reservation machines or their on demand. So the difference is going in and buying something right off the shelf, or having a coupon, essentially going in and using a coupon to purchase something. So you can see that they started tracking and they've been saving money kind of in conjunction between on-demand pricing and reservation pricing. And so these are the things that our customers are interested in. You know, there is no way really to understand the data that's coming out of a cloud provider like AWS or Google Cloud or Azure. It's essentially raw data. And so we're ingesting all of that data and then trying to make sense of it and trying to give some indication of what a customer should do. And so the second phase of this was an elasticity score and volatility score. So how efficient is their architecture running? You know, in this case, a higher score is a better indication of efficient spending. So you don't want to spend more than you need to, and you want to have all the capacity reserved if you need to increase capacity. And so these are very interesting problems in this space. and just a couple of tools that we've used in the past few months, built in the past few months to accommodate this, to solve these problems. And so, as I said, kind of some data product dragons that I run into typically. How did you arrive at that result? So show me the algorithm. Customers are savvy. There's only so much we can present to them until they say, well, how did you arrive at this conclusion? And so, this is something that we need to typically do. If you think of an example like maybe Spotify, like the weekly recommendation or weekly playlist, it's not typical that the customer would want to say, well, how did you arrive at this, how did you arrive at this list of music to recommend to me? Or even a recommendation engine. You can kind of determine that that's based on past results, your interaction, your social signals. In this case, though, we're really analyzing very large data sets, and we're making determinations. We're weighting things higher or lower in order to kind of have the algorithm display what we want to show customers. The other one is kind of forcing the model. And so I think this is a corollary to asking the right question. It's easy to say, well, we really have to answer this question. The data doesn't really match that, or doesn't provide the answer that we're looking for. Can we force it? Can we change the data to answer that question? And it's generally a bad idea. And then, as I mentioned earlier, with kind of this aspect of R&D project versus kind of production. A lot of data products kind of begin when they're kind of this nascent data project might begin as very small data sets, kind of massaging the algorithms, determining if the model fits, and then kind of doing a proof of concept, maybe showing it to some customers. Working as a product designer, this is one aspect of all of the designer work that we do here. We also have all of the other pieces of the product. But I think this one in particular is when we're kind of pushing the envelope, when we're trying to build something new, we do find ourselves in this process of determining what we're going to call something, determining how the algorithm is going to work, determining how the interface is going to work. And so I'm really focusing on that kind of early stage development of how you kind of determine what a meaningful data product is. There is also the kind of long tail of we do mock-ups, we do prototypes. They may be in code, they may just be a sketch prototype. We do click-throughs and we show those to customers. And so I can answer any questions you have about that piece of it. That's also a piece of it that I'm not quite focusing on right now, but it is a big part of designing meaningful data products. And so there's this kind of there is this kind of paradox of automation, and I think that's where a lot of this is headed. And so right now, in the example that I showed for underutilization, we're saying, we'll make the customer aware of this situation, but we take no action. We could just as easily say, we're going to let the customer know that we took this action, and the whole thing is automated. And so that's something that we kind of, we debate internally, is like, how much should we automate this, or how much should we just make the users aware of this? And so this paradox of automation is, if you're, a good example is with autonomous vehicles, for example. So if we're kind of, the direction that we're going in is, we'll let the machine handle the driving and the steering and the braking. And if the machine encounters any problem, then we'll request the human to take over. And the paradox in that is that the human is going to become more rusty and not have a great sense of what they should be doing. So you kind of lose. This happens in airline pilots, where they might be using autopilot a lot, and they don't have as much experience actually flying anymore. And so the counter argument to that is, well, how about let the human drive and have the machine observe, and the machine takes it over if the human makes a mistake. And so there's kind of a counter way to look at that problem. It's not discussed very often, but that is the paradox of automation, and just kind of humans kind of losing the ability to kind of sense making in the real world, and the ability to make decisions. And so I guess the last thing I'll say, kind of this idea of the world as its own best model is really, we've moved beyond this model to more abstractions, kind of layers of abstraction, but we still need data products to kind of be grounded in the world that we live in. The data products that I showed, we're still, these are still business decisions that need to be made. This is cost. This is money that a company is spending or saving. And so there are real world ramifications of the products that customers are using. And so they provide us with directionality, they inform us of actions to take. The data products we design really need to be respectful of kind of the basic human requirements. And I guess that's my charge for you as product designers. Don't forget that humans are ultimately at the receiving end of all of these products that we're designing, except for the case of machine-to-machine products. But I think capturing the best user experience, really being aware of the person in this whole process, I think is key, and really designing for kind of understanding and comprehension and sense making. I think that's all I have. The last thing, the ethics of data product design. I think this is probably more of an emerging field, but it has to do with the transparency of the algorithms that we're writing. There are things that I think we know to be true. It's easy to start mass movements in the social networks that we've created. It's easy to influence people at scale. We've gained really deep insight into the behavioral psychology of our customers. And so it's a double-edged sword. It's good and bad. And I think as designers, kind of we're really on the vanguard of bringing into existence what is possible. And so kind of the final question really is be aware of the line between what's possible and what's ethical. I think as designers we're kind of there's a team of people that are building these things, but I think our voice is really as the kind of representative of the customer, of the representative of the human in this whole system. I think I don't think the weight of that can be understated. So that's all I have. I hope you enjoyed this kind of quick dive into data product design. I hope it was entertaining as well. So thanks a lot, and any questions?
Great, thanks, Chris. We've got a lot of great questions here. So I think this will be a very interesting conversation. Some very technical questions as well, which I'm sure you'll appreciate. So I'm going to go ahead and launch the poll, which we have for every webinar here. And we can go ahead and get started here. So let's see here. So there's an actual very interesting question here around data access, right? So there's been some question around have you experienced a difficult time getting access to data during the design process? And if so, how do you get around that? Because there's some designers who work with folks who either refuse them access to data, or maybe certain data isn't available for confidentiality purposes. So how can you get that sort of realistic data to work into the product as you're building it?
Yeah, that's a great question, and I've been in that situation in the past. I have been in situations where there is highly secure data. One way that I've gotten around that, so in the context of cloudability and the work that we do here, the data is sensitive, but customers are granting us access to use the data to kind of build the product, make available to them for their decisions. But I have been in situations where the data is maybe private, or it needs to be anonymized, and I guess that's what I would kind of hone in on, is the anonymized data. There's really, I think a lot of times in product design we talk about us and them. We talk about engineering, we talk about product managers and designers, and there's friction between everyone. When the best experiences that I've had as a product designer have been working very closely with engineers or very closely with data scientists. And I think what I would tell you is, get to know the engineers, get to know the data scientists, be their friend, and then ask them for anonymized data. And so, typically when I've been in that situation, I've been able to negotiate, send me an anonymized data set. I don't need to know who the actual customer is. I don't need to know the identifiers.
There's some, Chris, there's some background noise, and you mentioned that it's harder to hear. Maybe it might help if maybe you face the laptop correctly. That might help with.
Yeah, is that better? I'll kind of lean in a little bit. Is that better?
Yeah, that sounds a little bit better.
Okay, yeah. So I think the answer to that question really is, try to request anonymized data. Unless there are situations where you really need user IDs and things like that. Typically, if you're modeling something, an anonymized data set is fine. And I think working with an engineer and letting them know what you're building, and kind of having a conversation around your requirements in order to build the data product. I think that's where to start. I don't necessarily, I don't know the specifics of this situation, but you can do a lot with data that's anonymized. And even, I guess the follow-up, the last thing I'll say on that is, if you're designing something and you know the model that you're going to use, make some data up. Just grab some data, populate a few sheets of a spreadsheet so that you can show a prototype. I think it's very valuable to kind of show a prototype, show an interaction, and then worry about getting the accurate data in.
Right. And could you actually go into a little bit more detail on how you clean the data? So is there, for instance, certain guidelines or specs that you have to provide to your data team? Because there's some people here who are working on data products, and they struggle with with the data coming in and just not looking great in whatever chart that they have designed. So they have to spend a lot of time going back and forth between cleaning the data and then actually iterating on the design. So curious to see how you're trying to resolve that.
Yeah, so we actually just went a scenario on a product that we're working on where some of the data was actually not available in the data set, and so we needed to accommodate that with the interface. There was actually an action that the customer needed to take to grant us access to that data. And so, in my example, I'm hearing a little bit of background from I'm not sure who that is. In our example here, the data science team here will run, they'll run a query and return a large data set. I'll typically take a small sample of that and then clean it up. So I'll use just Google Sheets or Excel or something, clean up the data that I have. I might need to, in a past project, I've needed to possibly add a dimension. So I'll need to actually change columns in the database, which actually changes the way that they queried the data. But then I'll send that back to them and say, can you modify your query to give me the data in this format? So it's kind of that back and forth of, I'll get a sample data set, I'll clean it to where I can use it, and then I'll send it back to the data scientist to kind of, so that they can update it and get it back to me, get the full data set back in the right format or cleaned up. That's kind of the interaction that we do.
Gotcha. And the let's see here. So somebody was curious also, are you using a charting library to plot all of these visualizations?
Yeah, we do. We have a combination. We use a combination of high charts, and then we also just use custom D3 or Dimple.js. Usually when I'm prototyping, I'll use Dimple.js. It's kind of a simple library to use, it's an API on top of D3. As we get into more custom data visualizations, we'll probably be doing more D3.
Got it.
Yeah.
And also, what are some of the accessibility guidelines that you guys have placed around the data, so that, obviously with data, there's going to be a lot of considerations around colors and, type sizes and things of that sort. So curious to see how you guys are working that in.
Yeah, that's a great question. So, typically we do have a style guide, and we have a palette, and we have a color palette that we use for charting, and we have a color palette that we use for the actual product. As far as accessibility, we do all of the data that you see in the product is available for download. So that's not the best. It's difficult to do data visualization for accessibility, but we do provide all of the data as download. So you can generate a report, for example, on some metric, and then you can download the result of that report into an Excel spreadsheet and do whatever you want with it effectively. So we don't lock the data into the product. The product is kind of a layer on top of the data that we get from the cloud provider, and then we can kind of make sense of it, organize it, report on it, and then we provide the information back to the customer. So as far as guidelines, we don't really have guidelines. We try to make everything available as a download or accessible in other formats. We do have customers who take data out of our system and bring it into another system like Tableau, for example. That's pretty common, and we don't have any issues with that.
Gotcha. And let's see here. Let's see where these other themes and questions are coming from. Okay. Oh yeah, somebody had a very interesting question, which is about, are there specific techniques or methods that you have found useful for simplifying really dense data visualizations? So for example, if you have a very information dense dashboard, how might you scale that back so that it becomes more comprehensible for users?
Yes, that's a good question. So, you know, in much of the product, and I just showed the kind of the single dashboard screen, and in a lot of other areas of the product, we'll use KPIs. So just kind of a metric, a KPI and an indicator, up or down, you know, good or bad, along with other, you know, charting other data. So typically we have all of the data available on a timeline, so you can see cost over time for some dimension or for some resource. But in things like, a good example, I think, is our reservation instance portfolio. So we have a portfolio that manages reservations or coupons that customers purchase from Amazon, for example. And in that respect, we really we try to make that information easily consumable with just a few metrics. So that's information that doesn't necessarily need to be charted, but we can show it in a KPI, or we can show options as just simple metrics. And so I think, you know, to answer the question, we really try to be diligent about not charting everything. You know, if something doesn't need to be charted, we'll just, you know, we'll add it as a visual element in a KPI. We do a lot of kind of bar graphing and line charting, and then a lot of KPIs. So I think it's really just kind of a design decision to not overwhelm the interface. A lot of the table that I showed for underutilized resources, that's really kind of the beta release of that. I think in the next version, we'll start to chart that data. It might be a scatter plot of where those resources fall on some price continuum. And so I think the goal in kind of data product design is really to make the information understandable as quickly as possible. You know, tabular data is great if you're going to do something else with it. And then really the sparing use of charts. So we do have the dashboards; those are all customizable. So we do have some customers that only have a few charts on a dashboard. We have other customers who have really, you know, gone, you know, the complete other end of the spectrum and have, you know, added, you know, hundreds of widgets onto a dashboard to track everything that they possibly want. So we don't necessarily, you know, we have best practices, and our managers kind of work with our customers to inform them of how best to set the system up. But we don't put a lot of guardrails on what they could put in their own interface.
Right. And of course, since you're dealing with so much data, what tactics do you recommend for actually prioritizing what's important to show? So for instance, sometimes people work with projects where the stakeholders or other other product owners might want just everything on the screen at one time. So how do you go about prioritizing that data set?
Yeah, so we have the complexity that we run into is, that's a good question. The complexity that we run into is typically around kind of the availability of data. And so we're ingesting so much data. You know, we're ingesting hourly data, and the data is changing. You know, a lot of these resources are billed by the hour. They change. Things are turned off. So the data is kind of this living real-time data set that we're working with. Limiting the amount of data, you know, we do have controls and filters to kind of narrow down, to kind of reduce the scope of what the user is looking at. And we typically start out, I think, in the, you know, a lot of our default UIs, we're starting out with a kind of a simplistic view. We don't disallow customers to kind of build a complex view, but we really, you know, we start out with a simpler view. And the other thing that we do is we provide a lot of kind of out-of-the-box reports. So, you know, based on our experience, a lot of customers need to see these 10 reports. If they're a finance persona, for example, they might need to see 10 reports. If they're in operations, they might want to see something else. If they're an engineer working on a specific project, they might want to see something else. So we do have different personas, and we kind of, you know, we do modify the interface based on what that persona is. You know, the finance user is typically going to want to know month-to-month spend on some resource, or they might want to know what team is spending more, or, you know, what team has the most underutilized resources across this organization. So there are various ways that the data can be sliced, and I think to answer the question is really, you know, initial load is kind of a minimal representation of what they could do, and then we give them the power to kind of go in and exploit the data.
Right, right. And let's see here. So now that we are pushing up on the hour, I think that is the last question that we will actually take.
Right.
Chris, thank you for taking the time out to present some of your insights here on data products. For everybody else, thanks for the questions too. We had a lot of great questions here. The next session we're going to have is about enterprise usability with Dylan Wilbanks, who is a director of user experience, and he's going to be talking about his principles and practices for enterprise usability and how it sort of relates to chain restaurants in a way. So I'm going to go ahead and drop in the URL there, and that is going to start at 2 p.m. Pacific time, so in about 20 minutes or so. Hope everybody can join us there, and that'll be the last session of the day, actually. So after that, we will have 2 more days of the session, tomorrow and Friday, and hope to see you guys all there. Chris, thanks so much for presenting today, and everybody else, thanks for joining. I'll see you in about 20 minutes. Take care.